Hello class. Before you start this video, I strongly advise you to review problem 1 where I go into details about arrival rate and then the service rate. All these formulas give you an overall idea and I went over a whole problem. So not right now we're going to work on problem 2 and 3 and then the last video is going to be for problem 8. They are all going to be assigned for your homework. 3 problems for this week, and then we're gonna have your midterm that is gonna cover everything that we cover up to this point right here. So up to chapter 11. So let's go ahead, and problem 2 is just using the same information from problem 1, but saying now that in the Willybrook National Bank waiting line system, see problem 1, assume that the service times for the driver teller follow an exponential probability distribution with a service rate. Actually, let me even make this bold right here. With a service rate of 36 customers per hour or zero point 0.6 customers per minute. Use the exponential probability distribution to answer the following questions. Well, how is this any different from problem 1? On problem 1, if you go to your book, you're going to notice that we work with arrival times. We're calculating arrival times, okay, right here, arrival rate. Therefore, this was your formula. On problem 2, it's, if you go back here, it's talking about service rate. That's the difference. Now we are going to be calculating how long it takes to service a customer. One is we are calculating customers arriving. Now we are calculating how long it takes to service the customer, in which it has this formula right here. It looks confusing, but really all you're going to do is you're going to have 1 minus exponential, and which in Excel, if you do in Excel, this does it for you. And then you're going to raise to the negative, and then right here, it's going to be your service time times the time that you're trying to define. And then they give you some examples down here. The probability of the service time of less or equals than half a minute. Do you see how it's not a full number? So less or equals, therefore you're doing the formula 1 right here minus, you're gonna just change this to over here. So 1 minus the exponential raised to the negative, and you know right here in this problem, the service rate was given to you as 1. So 1, your service rate, times what you're trying to define, the time, and then you're gonna have the answer. Okay, so that's what we're gonna be doing for problem 2. If you find all this boring and annoying, just think about when you go to Disney World, Disneyland, or Universal. Disney World is known to have a great system to calculate all this. So if you're curious in how they determine the arrival time, service rate, this is something that definitely they would be using. So let's go back to the problem right here. So it tells you we have 36 customers per hour, service rate. Actually, here should say service. So we have 36 customers per hour or zero point 0.6 per minute. It's the same value. They're just giving to you is in hour and minutes, which really you already have per minute. Here is if you had it like in, for example, 5 minutes, like problem 1, all you would have to do, you do the 5 minutes times your service, and then you would know would be 3 customers every minute. So remember, I put the formula over here so you don't have to go back to the book. So we're going to do arrival in 1 minute or less. Therefore, we're just going to look at the formula over here. We're going to do equals to, I'm going to open a parenthesis over here. So Excel understands there's more than one equation. And then minus, I'm going to open a new one. Oh, a new one over here because I'm going to do exp for exponential. And then I'm going to open one more parenthesis to put the actual values. So minus, we have minus my service time right here per minute times how many minutes I'm trying to do, 1 or less. and then enter is going to give me errors. I'm just going to let Excel fix the parentheses on its own. There you go. And that's your answer. So the service, not arrival. I copied this from problem one. So that's why it should say service, whatever you see arrival. Okay. And one more, and then here. Okay. So we have the answer right here. The service in 1 minute, a probability of service 1 minute or less is 45.12, which is 45%. Let's go ahead and do equals this value, and let's put it in a percentage. And if you want to put a couple more digits, there we go. Let me just go ahead and format right here the same right here for the next one. So let's do the next one. For servicing 2 minutes or less, well, you're doing the same formula as you did over here, but now you're replacing the 1 by 2. So let's just go ahead and drag it down right here. And let's make sure that this value, it's minus this value times 2 now. Oops, right here, times 2, which is 69.88 or about 70%. Okay. Remember, if it's right next to the period, that's 60. That's not 6. 6 would be 0, 6. 6% would be 0, 6. And even less, then it would be 0, less than 1%, then it would be 0.006. Be very careful with the digits in your midterm and your final exam. And now the last one, if you notice, is asking you for a service time no more than 2 minutes, which is different. So just like we learned with the bell curve and all that, all you're going to do, you're going to calculate this and you're going to subtract from 1, which is the difference, to show more than. So all we have to do really, we already calculate less. So we're going to have to do 1 minus this value right here, which is 30%. And we can go over here. And you're done with problem 2. So again, y'all looks very, sounds very confusing, but it's all a matter of following the formulas, and it should not be very confusing. Now with this, all the information for 1 and 2, I'm gonna be able to calculate 3, which I'm just gonna keep going. Okay, so use this single server drive up bank teller operation, refer to in problems 1 and 2 to determine the following operation characteristics for the system. If you go back to problem 1, you're gonna say the arrival date was zero point 0.4 customers. Okay, I can, is it per minute or per hour? It's per minute. I want to make sure you have the correct information. Okay, so we're working in minutes. And right here, the one we just did is 0.6, the service rate. The service rate is 0.6. So we're going to go over here is 0.6. Okay, so here is your arrival rate, and here is your service rate that we just calculated. So now we should have all the information to do problem 3, which is asking you to calculate the probability no customers are in the system. So it's a percentage, average number of customers waiting, average number of customers in the system, average time a customer spends waiting, and the average time a customer spends in the system. And I guess there's one more, the probability, which I already did, the probability that arriving customers will have to wait for service, which is going to also be a percentage. So I have put the formulas here so it makes easier for you to follow. If you're not comfortable with referring to cells, go ahead and calculate with the numbers or whatever works better for you, as long as you are showing me your calculations. Okay, so right here is saying that to calculate the probability that no customers are in the system is going to be equals to, I'm following this formula over here. Okay, let me open a parenthesis. I'm telling Excel there is more than one minus, and then the second equation is going to be your arrival rate divided by your service rate. Just let Excel fix the parentheses in the end. I'd rather get that annoying sound than put a wrong parenthesis and get a wrong result. Okay, so there you go. The probability that no customers are in the system is 33%, which is pretty good, one third. The average, good or bad, because not many customers are coming in. It could be considered bad too, depending on the business. Now the average number of customers waiting. Okay, we're gonna have to do equals to, I'm opening a parenthesis. We're gonna open another parenthesis because I'm gonna raise the arrival rate to the second power, and then I'm gonna divide that, and then I have another by my mu times my mu minus my arrival time. All I'm doing is to look at here. This is my arrival right here. Lambda is the average arrival rate and mu is the average service rate. So I'm just looking at the symbols and clicking on the values. Let me close, and not sure if I'm missing a parenthesis. Yes, that looks right. Okay, so then now let's do the average number of customers in the system. Well, we have calculated already the average number of customers waiting, therefore we are able to do this whole formula. So right here, we're gonna do equals to, well, the average number, LQ, the average number of customers waiting is 1.33, and we're gonna add the arrival rate divided by my service rate. And then I'm gonna, which is the average number of customers in the system is 2 customers in the system. You could put more digits, and you're gonna see it's still 2. Then now let's do the average time a customer spends waiting. Well, right here you're gonna need LQ again, which is your customers waiting divided by my arrival rate. So that one is simple. So it's LQ divided by my arrival rate, which is 3.33 minutes. The time, average time, so you don't have to round. It's good like this. So now the average time again that a customer spends in the system, not waiting, in the actual system. So now we have the average time a customer spends waiting. Okay, so equals to this value over here. Just following the formula. That what is WQ? Is that this value over here? Okay, divided by 1 divided by my service rate. So the average time a customer spends in the system is 5 minutes. And then now for the last one, what is the probability that arriving customers will have to wait for service? Which is as simple as you divide your arrival rate, so equals to your arrival rate divided by your service rate. Service rate, which is about 67%. The probability that arriving customer will have to wait for service is almost 70%. And the probability that no customers are in the system is the difference, which is 33%. Okay, so this would be problem 2 and 3. Again, I know it sounds confusing, but it's all a matter of plugging the numbers, the formulas, and you should be able to. And I'm gonna go problem 8 to see how we're gonna do an interpretation of some of those numbers. Okay, let me know if there are any questions. Thank you.